Good morning, IB Math. Moving on, we're going to take a look now at 6J, which deals with reciprocal trig functions. That's what the IB text is calling it, but we've seen these before, but we didn't call them this before. If you remember from right triangle trigonometry, if I have an angle, I've got the adjacent side, the opposite side, and the hypotenuse. And we know that the sine, S-I-N-E, we just call it S-I-N, of the angle, is the ratio of the opposite side over the hypotenuse. The cosine, we just call it COS, but we say cosine, we don't say cos, is the ratio of the adjacent side over the hypotenuse. And the tangent, T-A-N, and we say tangent, is the ratio of the opposite side over the adjacent side. We should know that these are the first three trig, and there's three more. We've got the cotangent, C-O-T of theta, cotangent of theta, which is the reciprocal of the tangent, so it's the ratio of the adjacent side over the opposite side. We've got the secant, S-E-C of theta, the secant of theta, which is the reciprocal of cosine, so it's the hypotenuse over the adjacent. And then we have the cosecant. Now this is a little bit interesting here, because we should have seen these already, and we think about cosecant as CSC of theta, the reciprocal of sine, so hypotenuse over opposite. But your textbook, instead of doing cosecant like this, CSC, your textbook is doing COSEC for cosecant. So whenever you see this, just realize that it's really this. And if you write that, that's fine. If you write CSC for cosecant, that should be fine. Now we should think of these functions in a slightly different way. This is how I want you to think about these. The what's called the inverse identities. Although inverse, you know what? I don't like the word inverse here. I think I might use the word reciprocal identities. Reciprocal is probably a better word there. So the reciprocal identities are this. The sine of any angle is the same thing as 1 over the cosecant. And remember, IB says COSEC for that. The cosine is 1 over the secant. The tangent is 1 over the cotangent. The cotangent is 1 over the tangent. The secant is 1 over the cosine. And cosecant is 1 over sine. And again, remember that they do something weird there for cosecant. All right, so let's look at a sample problem now. And the typical kind of starting level of this type of problem is, suppose I tell you that the cosine of an angle is 4/9. And I want you to find the other 5 trig values. All right, if we draw a diagram here, I've got an angle. Cosine is 4/9. Cosine is adjacent over hypotenuse 4/9. And I want to find the sine of the angle, cosine, tangent, cotangent, secant, cosecant. Well, I already know the cosine. The cosine was given to me 4/9. Now, if I already know the cosine, there's another one up there that I already know without having to do any work at all. What is it? The secant, the reciprocal of the cosine, would be 9/4. Now, all of these other trig functions rely on using the opposite in one way or another. So I have to find the opposite here. And of course, this is, I didn't put the little right triangle in here, but this is nice, well-behaved right triangle trigonometry right now. So we know a squared plus b squared equals c squared. 81 minus 16, 81, 71, 65. Square root of 65. 65, 75, 81. Yeah, there we go, 65. All right, so now I use the Pythagorean theorem to find this other side here. The sine is opposite over hypotenuse, root 65 over 9. The tangent is opposite over adjacent, root 65 over 4. And of course, if I know the tangent, I know the cotangent. Take the reciprocal, 4 over root 65, but let's rationalize the denominator. 4 root 65 over 65. The cosecant is going to be 9 over root 65. Rationalize the denominator. 9 root 65 over 65. So once we know one, we can find all of the other ones. Now notice that this angle theta is a first quadrant angle. If I gave you one that was negative, well, then we'd have to think about, well, what other quadrants could it be in? Like if I told you the cosine was negative 4/9, well, then that's going to be in the second quadrant. And if cosine is going to be negative, well, secant would be negative as well. Sine in the second quadrant is positive, therefore cosecant is going to be positive. What about tangent? Well, tangent is the sine over the cosine, which would be a positive over negative, would be negative, therefore the cotangent would be negative as well. The other thing that 6J throws at you is simplifying some expressions. So in simplifying them, rewriting them, for example, if I wanted to simplify something like cotangent theta times secant theta. Well, cotangent, I know, is 1 over tangent, which is cosine over sine. Secant is 1, whoops, no, it shouldn't be an equals, that should be times, right? Times. Secant is 1 over cosine, and they're going to cancel, and I get 1 over sine, but I'm not going to leave it like that. Now I know that that's actually cosecant. So simplifying identities there. So 6.J shouldn't be so bad. I want you to go ahead and do assignment 6J. It's on page 400, and it's 1 through 5, all of them. Number 1, evaluating the secant of pi over 6 minus the cotangent of pi over 3. Think back to your unit circle. Secant, what is secant? And rewrite them in terms of sine and cosine, make it a little bit easier on yourself. Secant is 1 over the cosine. So 1 over the cosine of pi over 6, and what is the cosine of pi over 6? Same thing with number 2. Number 3 is very similar to the last one we did, simplifying. So using all the trig identities, simplifying, rewriting, and now, given the reciprocal identities, and again, the best way to think about things like cotangent is to think about it as 1 over tangent, or just cosine over sine, and so on. All right, if you've got any individual questions, go ahead and post them. And I will, kind of short lesson today. It's one of those ones where I think I do 3 in one day. If not, I will talk to you again soon. Bye now.